All right, last day of, what month is this? August, very good. Last day of August, and we're going to talk about direct variation today. Direct variation. I'm sure most of you woke up this morning hoping that we were going to cover direct variation in class today, and well, for those of you that did that, your wish is my command. We're going to talk about it. And we're going to say that you can write a formula for a direct variation function in two ways. Ways number one is y equals k, which stands for a constant times x. And the other way that you can write it is that y divided by x equals a constant. Constant, or k, meaning that value doesn't change. So you're going to be asked to do a couple of different things today. The first thing that you're going to be asked is, for each function, determine whether y varies directly with x. So you're going to determine if y varies directly with x. You're going to determine if y divided by x equals the same thing every time. Okay? That's what they're asking you to do. Take each y value, divide it by each x value, and see if the answer is the same. If it is, then y varies directly with x. So then they're going to ask you, if so, what is the constant? All right, that's the k. If so, what is the k? Now, as far as simpleness goes, this is pretty simple. You're going to be given an XY table. You can either be given an XY table or you could be given some coordinates of points. But here you got your X's as 1, 3, and 4. You've got corresponding Y's at 2, 6, and 8. Direct variation, two ways. Ways number one. How was it supposed to happen? Way number one right here, y equals k times x. Or y divided by x equals the same thing every time. So look, if you take your 2, 6, 8, in each of these cases, if you take your y and you divide it by x, do you get the same number? Well, if you take 2 and you divide it by 1, that equals 2, doesn't it? And if you take 6 and you divide it by 3, you get 2. And if you take 8 and divide it by 4, you get 2. So does y vary directly with x? Yes. So you would write yes. What is the constant? 2. Perfect. Let's try it again. Let's take another XY table. Now we're given the X values 1, 2, 3. We're given Y values 4, 8, 11. We're asked to determine whether Y varies directly with X. So we're going to start dividing Y by X. All right. And in this case, what's 4 divided by 1? Good. What's 8 divided by 2? What's 11 divided by 3? Is it 4? It's not 4, is it? So it's not 4. So does Y vary directly with X? No. You're done. Well, that's the first part of it. That's the first part of it. Then there's going to be a second part of it. All right, the second part, then there's going to be one more part. So we're going to say the second part, your directions are going to be to determine whether Y varies directly with X. If so, find the constant. Same directions. All right, so watch. You just wrote this down a minute ago, but for direct variation, you got Y equals K times X, right? Or you got Y divided by X equals K. Either of those are direct variation. So let's say you're given a formula now, and you're given something like Y equals 15x. Does this formula match either of these formulas up above? Does it match the format of the first one or the second one? Doesn't it match the first? Doesn't it match the first one? Okay, so we can say yes. And what's in the place of the K? 15. So there's your constant. If you get something like Y is equal to 3x minus 1, does that formula match either of these templates? It doesn't, does it? All right, it's got this minus 1 out here. And neither of those examples have a plus or minus outside there, do they? So that's a no. Now, you may get something that looks like Y minus 5x equals 0. Now, you want to be careful here a little bit. They're trying to fool you. Don't let them fool you. All right? Don't let them fool you. Is this equation in either of these forms? Right now, it's not exactly, is it? There's not just a y on the left-hand side, is there? Or there's not a y divided by x on the left-hand side equal to just a number, is there? But if you took this equation and you added 5x to each side, which you're allowed to do you get y equals 5x plus 0? And you wouldn't write the plus 0, would you? So now that this equation's been manipulated a little bit. Doesn't it match this first one, the first example? So this is a yes. Yes. Well, if you good? All right. So this is a yes. And what's our constant of variation? The 5. Good. Because it's sitting where the k is. Third part of your assignment and final part of your assignment. Now watch. You're going to be told y varies directly with x. Period. So you know now that y is equal to k times x, or you know that y divided by x equals k. You know that. They're telling you y varies directly with x. Then they're going to give you these different situations. They're going to say something like, if y equals 4, when x equals -1, find x when y equals 8. You with me? Here's what we're going to do. In this situation, we're going to use this example, this template. We're going to say that y over x equals a k. The other thing that we're allowed to do here, if y equals 4 when x equals -1, we can say that 4 over -1, which is y over x, right, is equal to our other y over x, which is 8 over the x that we're trying to find. Y over x equals y over x. Now you've got a proportion, and in order to solve a proportion, you crisscross multiply. So you take 4 times x, and you make it equal to -1 times 8, which is -8. You divide both sides by 4. Your x is equal to -2. Let's do another one of those. We're going to say if y equals 20 when x equals 4. Find x when y equals 2. We're just going to do y over x equals y over x. So we're going to write a proportion. 20 over 4. equals 2 over x. We're going to solve that proportion by crisscross multiplying. So 20 times x is 20x. And 4 times 2 is 8. And we're going to divide both sides by 20. And your x is equal to, we'll take 8 and divide it by 20. 0.4. Anybody have any questions on those different types of examples? The 3 types of problems you're going to have in your assignment today. Say that one more time. Does this? Well, in this case, it does indirectly. Prior to this last example, you were asked if y varied directly with x, and you had to find out if it did. But in this case, you're being told that y varies directly with x. If you're being told that y varies directly with x, well, then you could use either of these formulas to find the missing variable. And we decided to use the fraction and make y over x equal to y over x, and then crisscross multiply. Yes? No, I'm not done talking yet. On the third, you're only going to do this when you're asked this question right here. Yes, or the y. All right, they may ask you to find the y, and in that case, you put the y on top and you put what the x is at that time on the bottom. If they say, if y equals 5 when x equals 1, and they say find y when x equals 3. Well, don't flip it, because you're still going to do y over x equals y over x. All right. So we're going to do 5 over 1 equals, now we're finding y. So we go y over x. That's all. It's still y over x equals y over x, but now we don't know what the second y, we don't know what the y is. So you can crisscross multiply. 1 times y is y. 5 times 3 is 15, and you're done. Still going to solve it the same way, crisscross multiply. All right, your practice problems for today. Page 71, 7 through 24. Page 71, 7 through 24.